This is lesson 5 in our rational functions unit, and we're going to do sketch graph B, f of x equals 2x over x minus 1. We're going to do some work without looking at Desmos first. So first we're going to define the restrictions. That's what the denominator cannot be. And if you set the denominator equal to 0, you can figure out what the restriction is. X would equal 1, and if 1 is x, then you'd have a denominator of 0, so your restriction is x cannot be 1. So that means the function skips over 1 basically, but it takes on every other value. So that's the notation for the restriction. If I know the restriction is either a whole, if it's a factor that crosses off, or it's a vertical asymptote. Well, it didn't cross off, so it's a vertical asymptote of x equals 1. So that means the graph is going to get really close to 1 but never touch it. So this is us graphing our vertical asymptote of x equals 1. I can also figure out the horizontal asymptotes by simply looking at the function. In the previous problem, the degree of the numerator was 0 and the degree of the denominator was 1, so the horizontal asymptote was y equals 0. In this case, the degree of the numerator is 1 because there's an x with no exponent, so that means it's 1, and the denominator has a degree of 1. If the degrees are the same, you simply take the ratio of the leading coefficients, which is 2 over 1, and that is your horizontal asymptote, which is y equals 2. And we'll see that, and we'll talk a lot more about this in class, so you're not expected to understand all this, right away. So this is y equals 2. So the function can cross that, and sometimes it does. But it can't cross the vertical asymptote. So now we're going to find the zeros. Well, to find the zeros, you set the function equal to 0, and you solve for x. Well, when you cross multiply, 0 times this is just 0, so you get 0 equals 2x. So x would equal 0. So the x-intercept is 0, 0. That means the y-intercept is 0, 0, 2. So right there is the intercept. And there is no other place it'll cross, but we'll verify that by finding the y-intercept. When you find the y-intercept, you plug in 0 for x. So I got 2 times 0 over 0 minus 1. Well, that has to be 0 because 0 divided by anything is 0. So we have the y-intercepts now. And again, we could pick some additional points and substitute them in to get an idea for what the graph looks like. So I just picked a few points. I plug them in for the x value, and I get my outputs. And we can also identify these on Desmos because all you have to do is scroll over a point on Desmos, and it gives you each point. So you can see that the graph is positive. It's above the x-axis. See here, it's positive, positive. Oop, not positive. It's positive, and then here it's 0. It crosses the x-axis, so it's 0. And then it gets negative, then it's undefined, and then it's positive again. So the graph is positive above the x-axis. It hits the 0, and then it goes negative. And then after the other asymptote, it's all positive. So it looks like this. But if you weren't sure, you could use Desmos and you would be able to see this. You can see that the vertical asymptote would be right here. You could actually draw an imaginary line right there. And the horizontal asymptote would be right here. And I can type in those equations if that helps. So if you do x equals, it was 1, right? See how the red line is getting really close to the blue line, but it's never going to touch it. And then the horizontal asymptote is y equals 2. And you can see that the graph is getting close to it. It might cross it, but it's not going to, otherwise it wouldn't be, well, it could cross it. So that just shows the asymptotes. All right, so that is B, and I'm going to stop there. I want you to try to do C, and then we'll go over that one quickly. Sorry to break this up, but I just don't want to make the videos too long for you.